Hello guys, my name is Ash Bissoy and today I'm back with another chapter, and today we'll be concentrating on science. So chapter 8 of a science textbook, which is motion, is our first physics chapter. So let's get started. So starting with, first you have to understand what is motion. Motion is the change of position of an object with respect to a origin. Origin means a reference point. For example, there's a reference point here, and we can say the object is 2 centimeter. So the object is 2 centimeter away from the reference point. If it changes its position, and suppose the object comes here, then the distance is going to change between them. So we can see that there's a change in the position of an object. So this change of a position in the object with respect to a reference point is called motion, and this reference point is called origin. Origin. Now, in this chapter, we'll be only learning about motion in a straight line. There are different types of motion, like motion in a circular line, motion in straight line, motion, oscillatory motion, etc. The uniform circular motion will come in the later part of this chapter. But before that, we will be learning some important terms and physical quantities related to motion, and we'll be only keeping in mind about motion in straight line. So let's move forward. Okay, imagine that you're moving from a point A to point B using this path. So this is a distance that you cover from moving from A to B. So distance is the length that you have covered while moving from one place to another. We have to know another physical quantity called displacement. What is displacement? Displacement is how much far or how much distance have you actually moved away. So the displacement is gonna be the shortest length between A and B. That is, this is gonna be displacement and this is gonna be the distance. So distance means the distance that you have actually covered, or the actual path that you have taken. Whereas displacement means how much far have you actually come from point A, or how much place have you actually displaced. It's called displacement. Now we'll see another example where we'll get a clear idea of the difference between distance and displacement. Look at this line. Here it shows how much distance you have covered. These numerical values shows how much is the distance between each gap. So here we can see that A and B have a gap of 10 kilometers and B and C have a gap of 15 kilometers, etc. So imagine an object is moved from A to D and comes back to C. So when you cover A to D, you are covering this full length, which is 50 kilometers, and then you're coming back to C, which is further 24 kilometers, 25 kilometers. So total distance that you have covered is 50 plus 25 equals 75 kilometers. But what is a displacement? Displacement is the distance between the initial point and the final point, that is C, which is 25 kilometers. So displacement is gonna be 25 kilometers. So here we get an idea of what is the difference between distance and displacement. Distance is the shortest length, or the distance displaced between the initial and the final point. Here the initial point is A and the final point is C, and the distance between them both is 25 kilometers. But the distance covered is how much totally length you have covered, or how much distance you have actually covered, which is 50 plus 25, that is 75 kilometers. Now let's list some points which will be important for us to distinguish or differentiate between distance and displacement. Okay, so these are some of the points which will help you to distinguish or differentiate between distance and displacement. The first point states us that distance is the actual length, or the actual path that is covered, whereas displacement is the shortest length between the initial point and the final point. Distance is a scalar quantity, which means that it only has magnitude. Example, we can only say that the distance between A and B is 25 kilometers. But displacement is vector quantity, which means it has direction and magnitude. So we can tell that the distance between the displacement between position A and position B is 25 kilometers to the right or to the left, which means it has a direction and a magnitude. Then displacement can only be positive. So distance is always going to be positive whichever direction it is, whereas displacement can be negative. Displacement will be negative if an object is moving towards the left side. If it will be positive if it moves towards the right side, and it will be zero if the final point and the initial point, that is the place from where it started, if it comes and ends in the same place, then there is zero displacement, there is no displacement. For example, you start from your home and you go and make a circle and come back to your home back, the displacement will be zero because you started from the home and you ended up at your home only. So the initial and the final point are same, so the displacement will be zero. The last point states that distance is always greater or equal to displacement, which means that displacement will either be less than distance or they will be equal. This is because distance is the actual length, so it will always be more than displacement, which is the shortest length. Now let's move forward and see what is uniform and non-uniform motion. Okay, let's see what is uniform motion. Uniform motion is when an object covers equal distance in equal intervals of time. For example, when we talk about uniform motion, we can see an example here. Uniform. For example, a car is moving at a speed of, for example, distance, and here we'll be writing the time. So, for example, at 0 seconds, it's 0 kilometers. Then after 0 meters, at 5 seconds, it moves 10 meters. Then 10 seconds, it moves 20 meters. Then 15 seconds, it moves 30 meters. So we can see here that after every 5 seconds, the car is moving 10 meters extra. So we can see here that the distance is being increased equally. We can see that there is equal, it's covering equal distance in equal intervals of time. Here the intervals are equal, there is 5 seconds intervals, and in these 5 second intervals the distance is increasing by 10 meters, 10 meters and 10 meters. So it is increasing with the same magnitude, it's covering the same distance. So this is an example of uniform motion, while non-uniform motion can have many variations. Now looking at non-uniform motion, where for example time and distance, if you take for example 0 0, then at 5 seconds it covers 4 meters, then at 10 seconds it covers 6 meters, then at 15 seconds it covers 10 meters. So here non-uniform motion means when an object covers um, different values or different lengths at equal intervals of time. It covers unequal distance at equal intervals of time. The interval has to be same. If the interval is equal, then only we can know if the object or the distance covered by the object is equal or not. So uniform motion is when an object covers equal distance in equal intervals of time, and non-uniform motion is when it covers unequal distance in equal intervals of time. So this is the difference between uniform and non-uniform motion. Now let's move forward and see what is speed. So different objects cover distance in different amount of time. For example, a car might cover a distance of 10 kilometers faster than a bicycle. It might take less time. So which means the rate of speed or the rate of distance covered is different. So to measure the rate of change in distance covered has to be measured. So it's measured through another physical quantity called speed. So what is speed? Speed is the distance covered per unit time, and it's a scalar quantity, which means it doesn't have any direction, it's only magnitude. So when you want to know what is the speed of a car, then we have to use the word speed. So what is speed? What's the formula of speed? So speed is often denoted with v, is denoted with v equals to distance, it is d upon time t. So this is the formula. So when we talk about speed, the formula that is speed equals the distance by time is very useful when the object is moving with uniform motion, because the speed will remain the same throughout the distance that you have covered throughout the time. But then if it's a non-uniform motion, the speed will keep on changing after some interval of time as the distance is not equal, because in a non-uniform motion means unequal distance in equal intervals of time. This is why we have to find the average speed. So average speed is equal to total distance by total time. For example, if you go on a tour and you cover something like 20 kilometers in 5 hours, or if you cover around 100 kilometers in 5 hours, that will be the average speed. It's not necessary that the car would have gone in that speed. For example, let us find out if a car moved 100 kilometers in 5 hours, it will be 20 kilometer per hour. But it's not necessary the car would have moved to 20 kilometer per hour throughout the 5 hours. For example, why do we use this average speed is because, for example, first 2 hours the car moved at speed of 30 kilometers per hour, and in the next 3 hours the speed just dipped below a little, and that's why it became 20 kilometers per hour as average speed. So here we can see that the speed was changing. So instead of keeping such a changing speed, we take an average speed. As I said, it need not be that a car moved with an average speed throughout the tour. It is just that it is an average, because we know average means the middle value. So that is what it is. So to find out the average speed, it is total distance by total time. For example, if a car moved totally 100 kilometer and it took it 5 hours, it's going to be 20 kilometer per hour. For example, if you moved around 50 kilometer in the first 2 hours and then other 50 kilometers in 3 hours, so the speed here is going to be 25, and here it will come in decimals: 53, 1, 3, 20, 6, 18, 2. So it's gonna come at like 16 to by 3 kilometer per hour. So here we can see that the speed is changing, due to which it's gonna be a bit different. So what we do is we find the average speed here. Now let's move forward and see what is velocity and what are the differences between speed and velocity. Now let us see what is velocity. So speed is the distance covered in a unit time. Velocity is the distance covered in unit time with direction. For example, if you cover 100 kilometers in 5 hours, the same speed is the same example that I had taken in right direction. You have gone, for example, you just went in right direction completely for 100 kilometers, then it's going to be the velocity is going to be 20 kilometer per hour towards right. But for example, as I have told, that here displacement can come. For example, you did cover 100 kilometers, but what if you went for 70 kilometers and you came back for 30 kilometers? So the displacement will just be 40 kilometer. So if you just displace 40 kilometer in 5 hours, it will be 8 kilometer per hour towards right. So here we can see that there's a change here. So what is velocity actually? Velocity is the distance covered in a unit time with direction. So what is distance with direction? Distance with direction means displacement. So velocity means the displacement in a given amount of time. So for example, we take here again. For example, we are A here and we are B here. You covered this 70 kilometers per hour and you came back 30 kilometers. So this is a displacement. For example, you stood here, that is C. Okay, this is C here, C. So here we can see that You covered 70 kilometers and you came back 30 kilometers. The distance total you have covered is 100 kilometers. That's the example I had given you for speed. So when you calculate speed, you will take it as 70. You will take it as distance equals to 70 plus 30 equal to 100 kilometer. So what's the speed gonna be? Speed is gonna be 100 by 5 equals to 20. But here, velocity means distance with direction, which is displacement. So here the displacement is only 40 kilometers. So what is the velocity going to be? The velocity will be 40 by 5 hours taken, 8 kilometer. 8 kilometer towards the right. Sorry. So it's going to be 8 kilometer towards the right, because it has come here till C, and C is towards the right direction of A. So here we can see what is velocity. Velocity can also be calculated through the same way, that is average velocity. So what is average velocity? If the speed changes, which means even the velocity will keep changing, because if the magnitude of speed changes, which means even the magnitude of velocity is changing. So when it is non-uniform motion, even the velocity will keep changing. So we have to find out the average velocity. What is average velocity? Average velocity will be final velocity. Final velocity means the velocity towards the end of the tour, like towards the end of the tour. What's the final velocity, or what is the velocity after the change? So that will be v. V means final velocity minus initial velocity, the velocity with which it started, that is going to be u. So that is v. Oh, sorry. So you add both the final velocity and initial velocity divided by 2. This is how we find average. So average velocity here is initial velocity plus final velocity by 2. Or you can also write it as v average is a displacement by total time. That is going to be the average velocity again. So this is what is velocity. This is a very new topic to us, and now we'll be seeing the difference between velocity and distance. Velocity and speed. So coming to the differences between speed and velocity. Speed means distance per unit time, which means distance covered in a given unit time, and velocity means the displacement per unit time. The speed cannot be zero. So the speed can never be zero, because if you cover a distance, it's always going to be positive. The velocity can be zero though. For example, if the displacement is zero, the velocity is also going to be zero. For example, if you go back and come to the same place, where the displacement will be zero and even the velocity is going to be zero. Speed is a scalar quantity. Again, so what is scalar and vector? Scalar quantity is the quantity which only has magnitude and no direction. So when we use the word speed, it means that we are only giving the magnitude or how fast the object is moving. But velocity is vector. It has direction and it also has magnitude. So when we use the word velocity, we also come to know how fast the object is moving and in which direction it is moving. So speed is always positive, as I had said. Speed will always be positive because you're covering a distance in a given amount of time. And velocity can be positive or negative because the displacement can be positive or negative. For example, if the car moves in a given amount of time to the left side, it will be negative. If it moves to the right side, it will be in positive. Now let's move forward and see what is rate of change of velocity or acceleration. So what is acceleration? Acceleration is a word we have heard very commonly in our day-to-day life. But what does actually the acceleration mean? Acceleration means the change in velocity, the rate of change in velocity. What does the rate of change in velocity means? It means the change of velocity in a given amount of time. For example, the car was moving with an initial velocity of 5 meter per second and it changed to 10 meter per second. So there's a change in the velocity, and this change took around 2 seconds. So what is the change? The change will be in the final velocity minus the initial velocity by the time given. So what is acceleration? Acceleration is equal to in a final velocity v minus u. So what is v minus u? It means final velocity minus initial velocity. This will give you how much the velocity has changed, which means the change of velocity, and how much time it took for it to happen. So it's t. So acceleration means rate of change of the velocity. So the formula for acceleration will be final velocity minus initial velocity divided by time t. For example, if the car was moving, as I said, if u is 5 meter per second and v, that is final velocity, is 10 meter per second, and the time taken for this acceleration is 2 seconds. So it is going to be, as a is equal to v minus u by t, it will be 10 minus 5 by 2, which is 5 by 2, or 2.5 meter per second square. So the unit for acceleration is meter per second square, and the acceleration here is 2.5 meter per second square. So this is how we calculate acceleration. Now let's move forward and see about graphs. Before we move to graphs, let's have a quick glance on what is the meaning of uniform acceleration and non-uniform acceleration. It's quite simple. Here, instead of we had learned what is non-uniform motion and uniform motion, the same thing applies over here. The difference is that instead of distance, we're talking about velocity. So if the velocity changes, if the velocity changes in equal amounts, in equal intervals of time, it will be uniform acceleration. For example, if the velocity is increasing by 5 meter per second every 1 second, for example, um, for initially it was 0 meter per second, then it changed, 1 second it took 5, then 2, 10, third second it became 15, fourth second it became 20. Here we can see that with every second 5 meter per second is increasing. So the acceleration here will be 5 meter per second square, as 5 meter per second is increasing every second. But if it's a non-uniform acceleration, but it is 0 0, and then first second it covered 5, and then after second it covered it became 7 meter per second, it increased by 2 only, then in third it became 10, so it increased by 3 only. So it's not increasing in a equal manner, it's very different, it's increasing in unequal. So here it's non-uniform motion. And the acceleration can also be negative. For example, when the velocity decreases, for example, take the initial velocity. If the car is moving with 10 meter per second and suddenly apply brakes, so when you apply the brakes, the car comes to its rest, which is 0 meter per second. And if you took time, for example, 5 seconds here, then as we said, a will be equal to v, which is 0, minus 10 by 5, which is negative 10 by 5, equals to negative 2 meter per second square. So negative acceleration is also called deceleration or retardation. So this means that acceleration can also be shown in negative, but this does not show direction. Here the negative sign does not show direction only. Yes, it may show the direction as negative also if the acceleration is towards the opposite side of motion. So if the acceleration is towards the opposite side of motion, is going to be negative. Or else if the velocity decreases, then even the acceleration will be negative. That's when acceleration is shown in negative. Now let's move to graph. So let's start with distance time graph. So here we have three examples of distance time graph. First example, we can see that it has been 5 seconds, still there is no change in the distance. That means no distance has been covered. It was in 40 kilometers and still in 40 kilometers. Okay, sorry. So this is gonna be distance, and this is gonna be time in seconds, and this is gonna be in meters. Same with here, time in seconds and distance in meters, time in seconds and distance in meters. So here we can see that in the first example, it's a line parallel to the x-axis. So whenever the graph of a distance time graph is a straight line parallel to the x-axis, this is the x-axis and this is the y-axis. So whenever it's parallel to the x-axis, it means that the object is at rest because there is no change in the distance covered. So there is no change in the distance, which means the body hasn't moved at all. Now moving to the second example. Second example, we can see that the body is moving and is moving with a uniform speed because first second it covers 20, the next second it covers 10 more, third second it covers 10 more, etc. So here we can see that with every second the body is covering 10 more meters, 10 more meters. So here we can see that it is an uniform speed. Now how do we find speed from a distance time graph? For example, if you want to find the speed at 30 seconds, so we will draw a line parallel to the graph to the for example 3 seconds. If we take, we have to draw a line parallel from 3 on the x-axis to the line, and then the same thing with the y-axis, we will draw a straight line. So here we find this point. So this point is going to be the speed. Now what is speed? Speed is distance by time. Now here distance is 30 by time is 3, which means 10 meter per second. So the speed is going to be 10 meter per second. It will be 10 meter per second if you take any second, because if you want to calculate what is the speed in the first second, it's going to be 10 meter per second. Even in the second second, it will be 10 meter per second because it's a uniform speed. The speed is constant. Now, when we move to the last, we can see that it's not a straight line, but it's a curved line. So when we see a curved line, it means it's a non-uniform motion. Now here we can see that in the first second, it hasn't covered any distance because it has to move, it has to reach till here. So now let's see, for example, that it hasn't covered any distance at all in the first we can't find it because this has to be from here and this will be 5 or something. So for example, first second it took 5, second second it took 15, and in third second it took 20. So here we can see that it's not equal, it's keep on changing. For example, if you want to find what's the speed at fifth second we can see it's coming from 40 over here. So we will draw a straight line parallel, and then here again parallel. It will be 40 divided by 5. So 40 divided by 5, which will be 8. Now if you want to find what's the speed at 3 seconds, we will draw a parallel line and again a parallel line. Here it's going to be 20 divided by 3, and we will get the answer something in decimals. For example, it will be 6 2 by 3, yeah. So that will be the speed. So we can see here that the speed is not same, it's changing. That's why it's a curved line. So these are some examples of distance time graph. Now we move to velocity time graph. Okay, so velocity time graph. Here we have 4 examples. First example is again a straight line parallel to the x-axis, but here it is not a distance time graph, it's a velocity time graph. So here it doesn't mean it's at rest. When you see this is the x-axis and this is the y-axis, and again it's a straight line. But here the velocity is 20 meter per second. So the velocity is 20 meter per second, which means the body is moving. In the first second, it's 20 meter per second. Even in the second second, it's 20 meter per second, which means the velocity is constant and the body is moving. That's why the velocity is constant. Now, if you want to find what is the displacement in second, in second 2, in 2 seconds, what has been the displacement of the object? From the velocity time graph, we can find the displacement and we can find out the acceleration of the object. So first, let's see how we find distance. Here, as I said, distance. What is velocity? Velocity equals to displacement by time, which means displacement will be v into time equals to displacement. When we take this to the other side, which means we have to multiply velocity with the time. And so we will again draw the line parallel. So we have to draw a line parallel from 2 seconds. If you're finding it 2 seconds, and here the line is already parallel. So what is the velocity? The velocity is 20, and it's 20 seconds. So the displacement will be, displacement is equal to 20 into 2 equals to 40 meter. So here we can see how do we find displacement. So displacement is the area covered under the graph. So when we multiply two sides, it's no, it's finding the area of the rectangle here. So we multiply this 20 and then this 2 here. We, this 2 and this 20 over here. So when we multiply two sides of a rectangle, which is length into breadth, it means the area. So the distance is the area covered under the graph. Now let's find acceleration. Here the velocity is constant, which means the velocity is not changing. What is acceleration? Acceleration is the rate of change of velocity. So we can only find the velocity, we can only find the acceleration if the velocity is changing. And here the velocity is not changing. It's a straight line, which means it's a constant velocity. So acceleration will be equal to 0 here because there is no change in velocity. Now coming here it's a uniform acceleration, which means the velocity is increasing in equal amounts. So here we saw first second it was 20, first second it was 10 meter per second, and in the second number 2 it increased by 10 more, it became 20 meter per second, and in third it became 30 meter per second, so it increased 10 more. So here again, if you want to find a displacement, we have to find the area under it. So again we have to find the area under this. So again here it's going to be 2 and 20, so the distance will be 20 into 2, which is equal to 40 meter. Now if you find acceleration, acceleration is a slope of the graph. So for example, if I want to find what's the acceleration at second number 3, so for what is acceleration? Acceleration is change of velocity minus 2 divided by the time. So here it is going to be, sorry, there's a mistake in finding the distance. So what we have to do when it is non-uniform motion is, again I'll be just drawing the graph, 1 2 3 4 10 20 30. So again I've just drawn the graph. So if you want to find the displacement in second number 2, you have to draw this, and we have to find the area of this triangle here instead of the square. So finding so if you want to find a displacement here, it's a triangle. So to find the area of this triangle here it was a rectangle. So we have to find the area under the graph, which is a rectangle. Here it's a triangle. So it is we have to use a formula, is 1 by 2 base into height. So the base is 2 here and the height is 20, which means 1 by 2 into 20 into 2, cut here, and then it will be 20 meter. So here we see that the displacement here is 20 meters. Now we will be seeing how to find acceleration. Acceleration here is, acceleration will be base by height. Height by base, which is a slope. So here height is gonna be 20 and the base is going to be 2 seconds. So it will be 10 meter per second square. This is how we find displacement and the acceleration from a velocity time graph. So the second example that we saw here is an uniform acceleration where the velocity is changing with equal amounts in equal intervals of time. The third example, if we see, it's a graph in which there's a slope, but it's a negative slope. The negative slope means if you see the line is coming down, which means that the velocity is decreasing. And when the velocity is decreasing, it means that we have, as I have given an example, it means we are applying brakes. So when you apply a brake, the velocity comes down and the acceleration will be negative, as I had said. So here we can see that the velocity is coming down as time progresses. So first it was 40 meter per second and it ends up at 0. So in such situations, if we have to find, for example, the area under the graph, sorry, So the area covered in 2 seconds. Now if you want to find the acceleration, or no, the distance covered in the end of 3 seconds. So the displacement is going to be, as I had said, the area under the graph, which will be 1 by 2 into base is 3 into height, which is 40. So 240, it will be 20, which is equal to 60 meters. So the displacement will be 60 meters. And when we come to acceleration, it will be again the height by base, which will be 40 divided by 3, which will be 13 1 by 3. So that is going to be the acceleration meter per second square. Yeah, so that is how we find from a deceleration. This is called deceleration because it is coming down. The velocity is coming down, and as the velocity is coming down, we know it's going to be deceleration, and that's why we give it a negative value. So in such questions, when the graph is showing that the velocity is decreasing with the increase in time, when we find the acceleration, we must give it a negative sign, because it means the acceleration is in the negative side because the velocity is decreasing. Now the last example shows the velocity is increasing but in a non-uniform way, which means it's a non-uniform acceleration. Here, for example, if you want to find if you want to find the distance it covered in 2 meters, we have to do this like this, and it's going to be a triangle. So we have to find the area of this triangle, or if you want to find the acceleration in 3 seconds, we have to take the height and divide it with the base to find it out. So this is velocity time graph. Now let's move to equations of motions. So let's see here equations of motion. So these are the 3 equations of motion. The first equation is final velocity. It is v equals to u plus 18. Here v means final velocity, u means initial velocity, a means acceleration, and t means time, which means that velocity is equal, the final velocity is equal to initial velocity plus acceleration into time. How has another alternative for this is acceleration equals to so this is the formula that we saw for finding acceleration, and when we rearrange it, for example, if we take t to the other side, it can also be written as a into t equals to v minus u, and it will be a t plus u equal to v. So here we just took the formula that we use for finding acceleration, that is final velocity minus initial velocity by time. So when we take time to the other side, it becomes a into time equals to final velocity minus initial velocity, and if we take initial velocity to the other side, it will be a t plus u equals to v, which is the formula that is given to us. Now the second formula. The second formula is used for finding the distance covered in the during motion. So it is ut plus half at square. U here is s means distance, u means initial velocity, time means t, and a means acceleration. So it states that distance equals to initial velocity into time plus half acceleration into time square. And the last and final equation is 2as equals to v square minus u square. Here v is final velocity, u is initial velocity, a is acceleration, and uh, s is the distance covered. So it means 2 into acceleration into distance or displacement is equal to the final velocity square minus initial velocity square. So these are the 3 equations of motion. Now we'll be moving to the last topic of our chapter, that is uniform circular motion. So what is uniform circular motion? What is circular motion? The motion of an object in a circular path. So when you are moving in a circular path, it is called circular motion. And when the speed is uniform, which means the speed you're uniform means you're covering equal distance in equal intervals of time. So it is a uniform motion. So when you're covering circular motion with a constant speed is called uniform circular motion. So as we know, For example, let's take a square, a rectangle. So here we have four corners, and at each of these four corners we have to change the direction. So when we change the direction, it means we're changing the velocity, because velocity changes with the change in either the speed or the direction, and the change in velocity is known as acceleration. The rate of change of velocity is known as acceleration. So here we can see that the object changes its direction four times. So the object is going to accelerate at four places. Now, for example, a circle. When you take a circle, you have to change your direction every second, because first you move here, then here. So every point you are changing a direction, which means a circular motion is an accelerated motion, because to keep moving in a circular path you have to keep changing your direction, and when you keep changing a direction you're accelerating. So that's why a circular motion is known as an accelerated motion, and then uniform circular motion means it is uniformly accelerated motion. Now how do we find the speed when you're moving to a circular motion? So as usual, speed equals to s by t, that is distance divided by time, and here the distance is going to be the perimeter or the circumference of the circular path. Now for example, if we take the radius to be r, then the distance covered will be 2 pi r divided by the time. So the speed of a circular motion is 2 pi r divided by t. Now let's see what is tangent. So for example, when you're moving an object in a circular path and suddenly you leave it, it will keep on going with the same direction. For example, if you're moving like this and you suddenly lose object, it will keep going in the direction from which you left it. For example, if you are throwing a stone and you're making a stone in circular path and you suddenly leave it, it will keep going in a straight line from the instant you left it. That line is called a tangent. The tangent is a straight line from the point where you left it. So this is where our chapter comes to an end. I hope you liked the video. If you liked it, please subscribe the channel and click the like button. Thank you.